This quote really says it all. For the last 20 years, we've been trying to solve machine speed problems at human speed. And that model, it's officially broken. The game has totally changed. And in this explainer, we're going to break down what the new rules are. Think about this number, under 10 minutes. That's the new window we're dealing with. From the moment a critical vulnerability is disclosed, AI-powered adversaries have a working exploit out in the wild. We're not talking days or hours anymore, we're talking minutes. Our old playbook of patching systems over a weekend, well, it's just not going to cut it. And that brings us right to the core of the problem, the total collapse of time. See, every defensive strategy we've built, every process, is based on the idea that we have time to react. Well, that assumption is gone. The rules have been completely rewritten, and they've been rewritten by our adversaries. And just think about how deep this goes. This isn't just about them scanning faster. We're talking about the entire attack lifecycle being compressed. Reconnaissance, exploitation, moving laterally through a network, delivering the final payload. Everything a human attacker used to spend days on now happens automatically in milliseconds. There's just no way a human speed response can even begin to compete. So, the big question is, how are they doing this? How are they achieving this kind of speed? Well, this isn't some far-off theory. This is happening right now, with a whole new arsenal of tools being deployed on our networks. Let's dig in and see what we're really up against. The threat landscape here is incredibly diverse. You've got these cloud-based services like WormGPT that make it ridiculously easy for anyone to create a perfect, convincing phishing email. Then you have these totally private, self-contained platforms like Xanthox AI that can run these complex autonomous attacks completely off the grid. But the real danger, that lies in the tools that orchestrate everything. Hexstrike AI, this is the real game changer. You got to think of it as a massive force multiplier. It connects these large language models directly to the same offensive security tools that we use. So an operator isn't manually running Nmap, then trying Metasploit. Nope, they just give a simple high-level command like exploit netscaler, and the AI agent just does it. It figures out the whole attack chain, runs the tools, and if something fails, it even retries. And that is how a single person can now attack thousands of systems all at the same time. And what this creates is a critical two-front war for us. It's not just about defending against these new AI-powered attacks. We also have to defend our own AI infrastructure. Every new model we roll out, every new AI tool we use, becomes a brand new high-value target for our adversaries to compromise, poison, or steal data from. So, how do we respond? The short answer is, as humans, we can't. The only viable path forward is to fight machine with machine. We have to start adopting our own autonomous systems to operate at the same speed and at the same scale as the threat itself. So this is what the modern Automated Security Operations Center, or SOC, looks like. It's built on 4 key pillars. First, you've got AI that actually learns what normal looks like on your network so it can spot any tiny deviation. Second, automation platforms that turn our team's expertise into automated playbooks that can run in seconds. Third, we need advanced analytics, things like graph neural networks, that can find those hidden connections in the data to proactively hunt for attacker infrastructure. And finally, agentic AI, agents that can investigate alerts for us 24/7. The strategic goal here is pretty simple. We have to reclaim the tempo. For years, we've been stuck in this reactive mode, just buried in an endless avalanche of alerts. We have to flip that. We have to move to a proactive model, using automated intervention to find and close security gaps before they can ever be exploited in the first place. But here's the thing. Even the best automated defense is still, fundamentally, a reaction to something. The true next step, the real evolution, is to get ahead of the game entirely. We need to start using AI to find our own flaws before they do. The vulnerabilities that really keep me up at night aren't the simple buffer overflows anymore. They're these subtle, tricky logic flaws. These are bugs where an application or a device violates the rules of a protocol, but it doesn't actually crash. It just enters this weird, insecure state. And our traditional security tools, which are basically just looking for that crash, they fly right past these every time. Okay, check out these 2 real-world examples. In one case, an attacker sent a Bluetooth packet with an invalid length. Now, the device didn't crash, it just accepted it, and that led to the state where communication just silently failed. In the other one, an attacker sent an encryption request at the wrong time. Again, no crash. The device just jumped straight to an encrypted state, but without a key. It completely bypassed its own security.
These are exactly the kinds of subtle flaws we need to be able to find.
So, how in the world do we find these invisible flaws? Well, we use a pretty cool new technique called semantic fuzzing. Semantic is just a fancy word for meaning. So, instead of just throwing a bunch of random data at a target and hoping for a crash, the AI first learns the meaning of the protocol, all of its rules. Then it intelligently starts crafting tests that are specifically designed to violate those exact rules just to see how the system responds. A perfect example of this in action is the BSF fuzzer framework. Here's how it works. First, an LLM does what no human analyst could possibly do. It reads and actually understands the entire 3,000-page Bluetooth specification. Then, based on that deep knowledge, it starts generating tests designed to break the very rules it just learned. After running the tests against real devices, that same AI analyzes the response. And if the device didn't handle the violation correctly, that's a bug. I mean, the contrast here is just stark. Traditional fuzzing is kind of like a blindfolded person with a hammer, just swinging wildly, hoping to break something and cause a crash. BF fuzzer, on the other hand, is intelligent. It's guided by this deep, semantic knowledge of the rules. So it finds a whole different class of these subtle logic bugs. It really is the difference between a brute force attack and a surgical strike. And the results, they're undeniable. This isn't just some theoretical lab experiment. On just 19 real-world devices, BS Fuzzer found 34 brand new bugs. That led to 9 new official vulnerabilities being published, and even bug bounties from major vendors. This proves flat out that this AI-driven approach is finding critical flaws that our human-led testing simply missed. So, all of this automation, on both sides of the fight, it leads to a huge, critical question. In a world where both offense and defense are automated, what's our role? What is the new mandate for us as human security professionals? I think this quote just nails it. This is our new reality. It's not about AI replacing us. It's about a new collaborative model. The AI provides the reasoning at machine speed, automation carries out the actions, and our role, our absolutely critical, irreplaceable role, is to govern the entire process. So what does it actually mean to be a governor? Well, it means we stop being ticket closers. We get elevated to a much more strategic role. Our job is now to design the automated systems, to oversee their performance, and to constantly find ways to improve them. We're finally freed from that mind-numbing repetition of alert triage so we can focus on what we do best: threat hunting, strategic planning, and thinking like the adversary, the high-value work that machines just can't replicate. So I'll just leave you with this one thought. The adversary is already here. They're operating autonomously. They're moving at machine speed. The only real question left for us to answer is, are we?